Hi everyone. Let's look at this question about the function. We are going to find the composite function for the fgx, fxx, and gf2. So given the function fx equals to 2 over x and the gx is 4 plus x squared, we're going to find the composite function for this function below. First of all, we look at the question A. Question A requires us to find fgx. In another way to write this function, this composite function is this. Fg in a bracket x. So first of all, I will put a bracket for the gx first and then look at the gx. What is the gx given in this question is a 4 plus x squared. So substitute the 4 plus x squared as our gx. We have your 4 plus x squared. Then consider the fx equals to 2 over x, meaning that if this remain as x, then you have the function 2 over x. If this x is changing into 4 plus x squared, meaning that this x is supposed to be changing to the same 4 plus x squared too. So what I have here is now 2 over, the x will be substituted as 4 plus x squared. So I have my 2 over 4 plus x squared. So if there is any chance to simplify, you need to do so. Okay, so I'll leave it. This is the simplest form, so I'll leave this as my final answer. All right, look at the B. B is given as f2x, meaning that these two represent the composite function f(f)(x). So first of all, again, I will put a bracket for the f(x), which is my first function. And the f(x) here will be substituted as 2 over x. What does it mean by the f2 over x? Meaning that this x going to be 2 over x. And this also the same, going to be the 2 over x. So I have my 2 over x. 2 over, so the x over here will be substituted as a 2 over x. So what does it mean by this statement? This means that 2 multiplied by 2 divided by 2 over x, meaning that if I change the divide into the multiply, meaning that these have to write down is a reciprocal. This should be a x over 2. So here we can see that the 2 can be cancelled off. Lastly, we have our x as my answer. Okay, so the C is require us to find the FG2. What does it mean by the FG2? Okay, it's a kind of a composite function, but we're going to substitute the 2 inside. We can also do in this way. All right. So the first function is function f, and then substitute 2 into the function f. What you have is substitute 2 into our function f. Okay, you have a 2 over 2. Meaning that here you have your 1, g1. You need to find your g1. What does it mean by the g1? Meaning that the x here now is changing into the 1, the same as this x. So you have a 4 plus 1 square. 4 plus 1 square. Then you have your answer as a 5. All right. Okay. So for the question 2, given the fx is 1 over x minus 3, we need to find the inverse of f. So I'm using this property to find the inverse, which is f inverse, composite function. F inverse is equals to x. So first of all, you will put a bracket for the f inverse, And now I'm going to find the f inverse. Actually, my objective is to find the f inverse. So what does it mean by the f inverse? Okay, so you can understand like this. Okay, fx equals to 1 over x minus 3, meaning that if the x substituted as your f inverse, which is exactly equals to what I want now, f inverse, meaning that in the bracket you put the f inverse. So f in the bracket you put the f inverse, meaning that this x will be substituted as a f inverse. Okay, so what I have here is now 1 over f inverse minus 3. Okay, this means that I have my f inverse. I have rewrite it into 1 over f inverse minus 3 according to the function given over here. All right, this is equals to x. So now I'm going to make the f inverse as a subject. All right, so we shall maybe you will say that, okay, I will move this all to the right side and move the x to the left side. So I will have my f inverse minus 3 equals to 1 over x. Okay, or we say that you can make a cross multiply maybe. Okay, then after that, okay, I have my f inverse x equals to 1 over x plus 3. Okay, for the question 3, sketch the following functions and state its domain and range. Okay, let's look at the question number 1, which is a. Okay, we are given the a function f is equals to 1 plus square root of x minus 2. So here to sketch this graph, I will start from my basic graph. My basic graph as the function of a square root of x, because I need to know the basic graph shape. I start from the y equals to square root of x, which is in the shape like this. Okay, this is x axis, y axis. And after that, I look at the inside the square root, there is x minus 2. So here I know that the graph of this basic graph need to be shifted to the right hand side for 2 units, which is you will have this now. Okay, you will have this now, and the shape still will be the same as this one. Okay, but here you will this is the graph of y equals to square root of x minus 2, which is you already shifted this original graph into the right hand side for 2 units. So after that, I look at the function given. Okay, this is not only they want the square root of x minus 2, it's still, after you have the square root of x minus 2, you need to plus 1, meaning that your graph now will be shifted upwards for 1 unit. Okay, so now your graph become like this. Original from the 2 over here, this is the reference point maybe. Then after that, you shift 1 unit to upwards. Okay, you have the, and the shape still will be the same as the first one, but now the reference point or all the points of the graph will be shifted 2 units to the right and 1 unit to upwards. So this is my x-axis, y-axis, and this coordinate shall be 2, 1. Okay, 2, 1. Okay, so from this graph, we can determine our domain and range very easily, which is domain. We will look at the value of the x which is allowed by the function or by our graph, which is it will start from the 2 and then go to the positive infinity. Okay, this is our domain. And the range we will refer to the value of y which is allowed to be taken by our function. All right, so the value of y we can shift, we can scan from the below to above, see with the graph start at which point of the y. So the graph start at the 1. Okay, the minimum value of the y is 1 over here, and then it will go, the graph will still keep on go up and non-stop to the infinity. So our range will be 1 to infinity. Okay, so this is the domain and the range for the question A. Okay, so now we look at the question B. Okay, 3b, fx is a quadratic, x squared minus 6x plus 10 for the x is greater than 3. Okay, why it restrict the domain? Normally the quadratic function, the domain is from order from negative infinity to infinity. But in order to make it into the function, it has to restrict the domain into the x greater than 3. But this is one of the methods. Okay, so if you would like to sketch the function of a quadratic, okay, I suggest that you try to complete the square first. Okay, to complete the square, maybe we have to make sure the 1, okay, the coefficient for the x squared to be 1 first. And how do I complete the square? First, I will copy the 2 terms, the first 2 terms. And then after that, I provide 2 brackets. One is a positive bracket square, the other one is a negative bracket square. And the constant, I will just copy it down. And then what do you need to fill in this bracket? You need to consider the coefficient of the x. Coefficient of the x here is negative 6. So we just put negative 6 over 2 inside the bracket, negative 6 over 2. So the first three term we are going to write into this form. All right, this first 3 term, I'm going to write it into this form, x minus 3. How do you get a negative 3? That it will be obtained by this negative 6 over 2. You get negative 3 square. All right, meaning that if you expand this, you will get back these 3 terms. So left the 2 constants, you need to simplify. which is this is negative 3 square. You got negative 9 plus 10. Okay, so simplify some more. You will get your constant to be a positive 1. So from this completing square, okay, from this process, you can see that, okay, this is a very useful form, which you compare to this form, x minus h squared plus k, okay. If your quadratic equation has successfully changed it into this form, you can very easily to determine its a minimum point or maximum point. So consider the a. If the a is greater than 0, which is the a now here is 1, which is a greater than 0, meaning that this quadratic function having the minimum point, and the minimum point is given as hk. All right, taking the value over here and convert the sign, you get the h, and then the y value over here is the k. This is a minimum point. So now look at our question. We have our minimum point, okay, as a 3, 1. Okay, this is a minimum point. So at our graph, if you want to sketch a graph, you can just refer to the minimum point first. Okay, have your axis, x and y. Remember to label the x, y. And then plot your 3, 1. This is a 3, 1. Plot it. And you know that this graph having the minimum point, which is you have the shape open upwards. All right. So now the question asking for the domain to be greater than 3. Now you just draw, okay, delete the left hand side, okay, because the quadratic graph is actually symmetry to each other. And now you have the minimum point over here. So for the x greater than 3, you only want this part, which is the right hand part. And then this left hand side, you got to eliminate. So now I'm going to sketch this part. Okay, so this is my graph of quadratic, which I have a minimum point at 3, 1. Okay, remember to sketch, to label this as a 3, 1. And since now here we only allow the domain to be greater than 3 without the equal sign. So here, this point, I will use the empty circle to plot on it. And this is my graph, okay. Should you label it as y equals to fx. So from this graph, we can get our domain by just scan, okay. You take a pencil, scan from the left to right. So the first point that you see is at the x equals to 3, which is not include the 3, because here the empty circle means that the graph is not include this point 3, 1. So until the infinity and the range of f, okay, you scan, you take a pencil, scan from the below to, okay, to upwards, okay. From the below, you scan, the first point that you see is this one. And what is the y value? The y value is 1, meaning that the minimum y value is 1, but it's not include the 1. So you put the bracket over here. And then after that, okay, that will be until infinity, because the graph is keep on going up like that. Okay, so this is your domain and range for the question 3b. Okay, so thanks for watching my video. Please remember to submit your paper by 2 o'clock this evening.